Alright. Alright, homework number 5. You better not record me, Patricia. Thank you. Hope you never record me. Alright. So we have... How many meshes does this circuit have? Basically, how many closed circuits are there? So there's 1, 2. There's your first answer is 2. Then it wants to do... it's basically write a KVL to find the current in one loop. That's how you do mesh analysis. Also the mesh current method. And how you do that is like so. Hold on, let me put this back over here. You take what we already have. It's this little power. V1. Got a resistor there. Got another power. V2. Plus, minus. Then we have another resistor up here. Going down, we have another resistor here. And we have another resistor there. This one is 8,000 kilo ohms. This one is 1,000 kilo ohms. This one down here is 2,000 kilo ohms. And this one here in the middle is 5 kilo ohms. Okay. And we do the mesh analysis like so. We go draw like a little loop, and this will be I1. This one will be I2. And we need to find all of the each KVL in each loop. So you do that as so. So the KVL of this power node here, V1, is just going to be, since in the loop we're going from negative to positive, it's going to be negative V1. And then plus, right? We need to find the voltage here, 8 kilo ohms, which is just going to be voltage is equal to resistance times current. So the resistance is 8,000 times I1. And then we have the next one in the loop, which is 5,000 kilo ohms. So we're going to do voltage is equal to R times I again. Resistance is 5,000. And the current, which is I, is just going to be I1 because we're doing the analysis here in I1 minus I2 is equal to 0. And that's going to be for I1 for mesh I1, and then mesh I2 is going to be, I'm going to do everything the same way. We're going to start at V2 here. It's going to be negative V2, going from negative to positive, um, plus resistance 2000 times I2. That's equal to voltage. Now we got to do the 5k ohm. And for this one, since we're doing I2, 5,000 I2 minus I1 this time. Because we're doing it with I2 and the direction of this arrow's up, and to get the current going up, we have to do I2 minus I1. Then for the next one, we have the 1,000 ohm resistor up top, which is just going to be 1,000 times I2. And that is both of the meshes drawn up. And so how it looks on the homework with the numbers substituted in, this is the mesh for mesh 1 that we just did. And this is mesh 2 with the numbers substituted in for the voltages. Now next you have to do a matrix. And to set that up, you do it as so. So, hold on, let me get my numbers back real quick. Put them over here. Okay. So our numbers that we have for each matrix. Alright. So for our first one, since we know the voltages, which are V1 is 25, V2 is 39, right? Since these are negative, we'll add them over and they can be constants. So we'll set up as V1 is 25 plus it over. We'll have 25 on the right is equal to. We will then factor out I1. And then we'll have 8,000 plus 5,000. That'll be I1 plus I2. And we have negative 5,000 there. See, we did that. We pulled that from up here. This top one here. We just substituted V1 in. And then we have to do it for the next one to get the next part of the matrix. The V2 is 39. Negative 39 plus it over makes it positive is equal to. Factor out I1. We want to make sure that we keep our matrix lined up so that when we plug it in, it doesn't get messed up. Plus I2. For I2 we have 2,000 and 5,000. Oop, did not know what that is. Let me move this over real quick. This one's a little bit longer. 2,000 plus 5,000. And that is the setup for our matrix. So how it's going to look is we're going to plug in our numbers for I1, which is going to be 13,000 for the first one. Separate this with a slash. You don't do that on your calculator, but just so it looks nice. Negative 5,000 here, and then 7,000. And then we'll have our variables here. I1, I2. Since we have I1 the first one and I2 is the second one, and the way we have it set up, that is how our variables are going to be listed, is equal to the matrix on the right, our constants 25, 39. And then we divide this matrix over. So then we'll have 25 over 39, not like a fraction. 39, this matrix. Then we'll have 13,000 and 5,000. Negative 5,000. Sorry, Batisha, we don't have any tissues. Set. We do. Yeah. And since you divided it over, it would be 1 over this matrix. But we can just bring it up with a negative 1 exponent is equal to I1, I2. And that's how you solve for the matrix, right? And then we'll go to the next set of problems that you need. So after you solve the matrix, we find I1 and I2. I1 should be 5 milliamps. I2 should be 8 milliamps. Yep. And then since we have the current going through them, now we can plug it into all of our numbers, and this is what you should get for your numbers. So for I1, which is 8 milliamps, and then you can 8 milliamps times 8, um, 5. I1 is 5. And power is equal to R times I squared. So it would be 5 squared times 8,000. You make it 8,000 so that your units come out right. And you can leave milliamps and milliamps so that it comes out as milliwatts. So you do 5 I, the current squared, is equal to R. That's our formula for power. And then our formula for power here at V1 is going to be the current is going around from negative to positive, so our sign convention will make it negative, right? Power supplied, I'm sure, is what that'll be. Absorbed is positive, so this is the supplying power. So voltage will be 25 times 5. That's your number there for power. And then for this number here, um, you'll have I1 minus I2. That's for the current here. You do I1 first because I1's going in a circle like this, going down from positive to negative so that you get the current going down the way you want it. And if you were to pick I2 first, I2 minus I1, then you'll get the current going up. That's not what you want. You want it to go down because it's asking for the power from positive to negative. So you'll have 5,000 I1 minus I2. Are you about to get robbed? Oh, he's here! Lord Ben. Lord Ben. And all these are pretty self-explanatory. But yeah, that's how you do the mesh analysis. You do this the same way. Here. And here are your number. And how many meshes? Two. Two closed circuits. Do KVL. KVL for the first one is simple. Now the only one that might throw you off is this uh for this one the node analysis for I1 is so just like we did the previous one. It's pretty simple. I'll do I2 so it makes a little sense. Let's see. Our circuit, I'll just draw what's important. Alright. So we have a resistor here. I'm just going to draw the circuit portion with for I2. Here's R. dependent current source I sub x plus minus then I sub x is given to us going down this way. I sub 1 is over here. Then we have I sub 2 over here. These values are 10 kilo ohms, 50 kilo ohms, and that's that. Alright, how do we do I2? Do I1 like we've been doing. I2 is the same, just this dependent current source here makes it a little weird. So this itself is already a voltage source. It's a dependent current voltage source. It's a dependent current. It's already in volts, but we just it's an unknown Ix. Right? We need to plug that in. So as we go around from positive to negative, the voltage source is positive 75,000. And how we're going to fix that Ix is we're going to plug in for what Ix is. We're given Ix here, right? It's a current. Well, the current's going down, and the current that's leading it going down is I sub 1 minus I sub 2. And that's the current for I sub x. And then you do the rest the same. Plus 50,000 I sub 2 minus I sub 1, since we do I sub 2 first because we're doing it for I sub 2. Since I sub 1 may be first here, but we're plugging in what I sub x is. Plus 10,000 I sub 2. And that's our mesh for I2. Oops. It tells you to do it like this, but then it's going to tell you to see I sub x here is equal to I sub 1 minus I sub 2. You can plug that into I sub x, and now you have your variables in terms of I sub 1 and I sub 2, and then you can solve for the for I sub 1 and I sub 2 in a matrix. And you should get these numbers. Yeah, power generated is same thing as power supplied. This is negative values, right? The resistors are positive. We're looking solely at the two voltage sources. But yeah, I'll go in more detail on that in another video. This one involves another current, which in this we'll get a super mesh. Here's some of the answers for this. Yeah. And the idea behind the super mesh is you can then combine both of these circuits into one single one. So you just do it as one whole thing, basically, instead of the way you do. And then you also have to, um, you still label, like, that you would do I sub x times 3000, and then you would do this one as, like, I sub y, or no, 1000 times I sub y. You still keep the variables here, but you just you just write it as one big one. And that you also have to solve for this current source too, and make that part of the equation. I'll show that in another video. Yeah, that's all I'm gonna do for now.